Hello. Today's lesson is going to be discussing what is a system of linear inequalities. The first thing, a system of inequalities is typically given to us in two variables and consists of at least two linear inequalities that use the same variable. So the letters are going to be the same in all the equations. There's going to be at least two equations that are connected in some way. The second thing about systems of inequalities is the solution to the linear system is any ordered pair that would be considered a solution to all of the inequalities in the system. Just a short reminder, inequalities are the greater than symbol, the less than symbol, greater than equal to, or less than equal to, instead of an equal sign. However, before we get into solving the inequalities, I just wanted to look at solving a basic system by graphing. So we have two equations here. Y is equal to 3x subtract 2, and y is equal to negative 1/2 x plus 5. As we said the other day, we're going to, the general strategy to solve this system to find out which value of x and y is a solution to both of these equations would be to graph each one. So I'm going to start off with the equation y is equal to 3x minus 2. Now, like we said the other day, we're going to find our b value for a linear system, which in this case would be negative 2. And so on the y-axis, I'm going to find negative 2. And then I'm going to find my slope. My slope on this equation is 3, but we want that to be our fraction. So I'm going to make that 3 over 1. Remember, if it's a whole number, we can always put it over 1 to make it into a fraction. So we have our rise of 3 and our run of 1. So that's going to be rising 3 would be up 3, run 1 would be to the right 1. So I'm going to go ahead and I'm going to graph it, and I'm going to graph as many points as I can so that I have an accurate representation of what the graph should look like. You never want to just kind of freehand the graph. You always want to make it as accurate as possible, because if you don't, there's a good possibility you could receive an incorrect solution. So I'm just continuing the pattern of up 3 spaces and to the right 1. And I would want this to go all the way to the edge of the page, just so I'm sure that I know what points are on this system. After I'm finished, I'm going to go ahead and connect the dots. Which gives me my line y is equal to 3x minus 2. Now I want to go ahead and graph the second line. The second line is y is equal to negative 1/2 x plus 5. So I want to find my b value, my y-intercept, this time of positive 5, the value with no x. And I put that on the y-axis. The next thing I need is my slope. Our slope is the multiplier of x, so negative 1/2. So I can see that, hey, the slope, the numerator, the top of the fraction, corresponds to my rise. My denominator corresponds to my run. So I'm going to be looking at, instead of rising 1, I'm going to be running, or I'm going to be going down 1 space, and then I'm going to be going to the right 2 spaces, putting a point. And I'm just going to kind of continue that pattern several times until I can make sure that I've got an accurate representation of what y is equal to negative 1/2 x plus 5 should look like. And then I'm going to connect the dots. Now when I look at this equation, I can see that yes, there is a solution. The one spot where the two graphs intersect, the red line and the green line. So I'm not talking about the slopes. I know it looks like the slopes are covering up both lines, but the only thing I'm interested in is when does the red line and the green line cross. And looks like they cross at 2, 4. So when x is equal to 2 and y is equal to 4 is the solution to this system. Now, this was a system of equations, and So one thing that we kind of need to remember is that a solid line represents an equation that is equal to y. So that's going to lead us to a note about our inequalities. If the equation has a greater than equal to or less than or equal to sign, or equal to, we use a solid line on the graph the same as if it was just equal to. If the equation is greater than or less than, so it does not have the equal to part to it, we cannot use a solid line. Instead, we're going to use a dashed line on that graph instead. So what we're also going to look at is we're looking for all ordered pairs that are solutions to the system. So any value of x and y that will be making the both or all of the equations in the system true. So the last thing that we're going to be doing is we're going to be kind of shading different regions. We're going to be coloring in different regions. And these different regions will kind of be a visual representation of where the actual solutions are at. So if we see a less than or equal to symbol in the equation, we will be shading below the line. And the reason why is graphically, when we're looking at y values, lower y values, smaller y values are going to be beneath it. And just the opposite, if we have greater than or a greater than equal to symbol, the solutions will be shaded in the area above the line because larger y values are going to naturally be higher. And so let's take a look at our first system of inequalities. So we have 3x plus 2 is less than 2, or 3x plus y is less than 2, and y plus 1 is greater than or equal to x. So the first thing that I notice on both of these equations is they're not set up as y equals. So the first thing that I want to do to both of these equations is change them to y equals. So I'm going to take my 3x plus y is less than 2, and I want to isolate the y. So to get y by itself, I'm simply going to subtract 3x on each side. So 3x subtract 3x would be 0, leaving us with just the positive y. Then we have less than. Now I know my x needs to come first in the equation, so I'm going to write my negative 3x, and then the 2 is positive, so I'm going to put a plus 2. And now I've got a linear equation. That's pretty simple to graph. We're going to find our y-intercept, which is our b value, so our b value is 2. We're going to find our slope, which is negative 3. And I'm going to go ahead and turn that negative 3 over 1 to make it into a fraction. I'm going to go ahead and graph that. We've got our positive 2 on the y-axis, and our slope is down 3 over 1. I'm just going to generate a couple of points going back the other way, just because I don't know where the solutions are going to be at yet. And the most important thing is to generate accurate graphs. Now the next thing is we need to look at our inequality. So this is simply less than. It's not less than or equal to. So when I connect the dots here, I'm going to be using what we call a dashed line. It's not a solid line. If I use a solid line, that implies that the equation was equal to y at some point. And I'm going to go ahead and put arrows on the end to signify that the graph will continue going in each direction. Now, this equation said that it is also less than. And when it's less than, that means we're going to be shading below. And so what that means is I'm going to grab a highlighter and I'm going to color below the line. So I'm just going to start maybe like 1 point directly beneath the line and just start shading in that section. So you can see this entire under area of the graph. All of these x and y coordinates would be considered a solution to this first equation, or to this first inequality of y's less than negative 3x plus 2. Now I'm going to graph the second line. So y plus 1 is greater than or equal to x. And again, I'm going to do the same thing. I want to get the y by itself. So I'm going to subtract 1 on each side. When I do that, I've got y is greater than or equal to x, subtract 1. So I've got my b value of negative 1, and I've got my slope. I'm looking for the value in front of the x is missing, so we talked about that needing to be a 1. And I'm going to go ahead and turn that to a fraction, 1 over 1. So I know my y-intercept on the y-axis, I'm going to find negative 1. And then my slope was positive 1 over 1. So I'm going to go up 1 over 1 on each of these points. And I want to go as far out as I can, just so I have a very, very accurate representation of where it's at. Okay, now I do see that my inequality, the greater than equal to, the or equal to means I need to use a solid line. So I'm going to go ahead and connect the dots here with a solid line. And the second thing is it's greater than. Since it's greater than, we said that we're going to be shading above. So I'm going to be grabbing my highlighter, and when I'm going to just start 1 point above it, and I'm just going to color in the areas of the graph that are above the red line. So you may want to use some colored pencils, you may want to use some markers on this. Now our solutions. Any point from the overlapping area would be considered a solution. So we're going to be looking at our overlapping area, which I'm just going to go ahead and outline in blue. So we've got this little section here, we've got our line right here, and we can see that, hey, the part where they both overlap is this top left section. Okay, now any value that would be in this section would be considered a solution. So if I asked if the following were actually solutions to this system, if I said, is 0, 0 a solution? Well, we look at 0, 0, the origin. Hey, that is in the blue section. So yes, this is a solution. If I looked at the coordinate 1, 4, okay, right 1 up 1, 2, 3, 4. At 1, 4, that's only in a red section. It's not in a blue section, so no, that is not a solution. Okay, if I looked at 0, negative 4. Okay, 0, negative 4, just down 4 from the origin. Hey, that is not a, that's only in the green section, so that means this is not a solution. If I was looking at the coordinate negative 3, positive 3, okay, so left 3 spaces, 1, 2, 3, up 1, 2, 3. That is in the blue section, so yes, this would be considered a solution. Okay, are the only solutions to this system 0, 0, and negative 3, 3? Absolutely not. Any value that could be considered in that blue area would be, in that overlapping area, would be a solution. Okay, so our next equation, just to do a couple of these so we've got kind of an idea of what we need to do on the assignment. What we're going to be doing is we have 8x plus 4y is less than or equal to 12, y plus 2 is less than 1/2 x. So just like the last problem, I'm going to start by taking a look at the first equation and solving for y. So I've got my 8x plus 4y is less than or equal to 12. So to solve for y, I'm going to start by subtracting 8x on each side. That leaves me 4y is less than or equal to negative 8x and a positive 12. Now, to finish solving for y here, I'm going to divide everything by 4. 4 divided by 4 is going to cancel out, leaving us y is less than or equal to negative 2x plus 3. So there's our first equation. I can see my slope. My m value is negative 2. I'm going to make that negative 2 over 1. My y-intercept is positive 3. So I'm going to find positive 3, and I'm going to go ahead and start graphing this. So again, I'm trying to be as accurate as possible, so I want to use as many points as I can on this. The second thing is I need to know if I need to use a dashed line or a solid line. Okay, this is equal to, which means we use our solid line. I'm going to go ahead and put my arrows on the end. Okay, the next thing is I see that it is less than. Okay, we said when it's less than, we're going to shade below. We're going to shade values that are smaller than that. So I'm going to come to my graph, and I'm just going to color in the area that ends up below the line. Okay, after I've finished that one, I'm going to go to my second equation. So our second equation, y plus 2, is less than 1/2 x. So I'm going to isolate the y, so I'm going to get rid of this plus 2 by doing minus 2 on each side. So y is less than 1/2 x minus 2. So I've got my slope of 1/2, my y-intercept of negative 2. So I come to my graph, y-intercept of negative 2, and a slope of positive 1/2 means I'm going up 1 and to the right 2. And again, I'm going to put as many points on the graph as I can. I want it to look as accurate as I possibly can. So we want to go in both directions. Now this equation is not equal to, so I need to use a dashed line. I'm going to put my arrows on the ends. And the second thing is this equation is less than. Same as the first one, which means we're going to shade below. So I'm going to come to my blue line. I'm just going to pick a point that's a little bit below it, and I'm going to start coloring. Okay, so the blue section is all the values that would be considered a solution to only y is less than 1/2 x minus 2. Now this does give us a very large overlapping area down at the bottom. Okay, so I'm going to kind of highlight the overlapping section in purple this time, just so we can kind of see this a little bit better. So all of that overlapping area would be considered the solutions. So let's just kind of see, hey, which ones of these could actually be considered solutions? Would the origin be considered a solution to this problem? No. The origin is only in the red section. If I looked at 0, -3, would that be considered a solution? Okay, 0, -3. Yeah, that is square in the purple section in the overlapping. So yes, that is a solution. If I look at 5, -1. Okay, 5, -1 is only in the blue section, which means, hey, this is not a solution. If I'm looking at, say, -2, -3. Okay, -2, -3. Okay, that's right on that dashed line. So that dashed line means it's equal to, which means unfortunately we needed less than. We needed to be directly underneath it. So this would not be considered a solution. Okay, so I'm going to put up another example. I would highly recommend you pause the video. You try this problem on your own in your notes. When you're finished, push play, kind of check your work if you need to. Pause the video while I'm working it out so that you can kind of compare your work to mine. Okay, so the first thing that I did was I took the first equation, -3x plus 2y is greater than or equal to 2, and I solved for y. I added 3x to both sides, then I divided everything by 2, and that gave me the equation y is greater than or equal to 3 over 2x plus 1. Once I had my equation in slope-intercept form, I recognized that my slope was 3 over 2, which was a rise of 3, a run of 2, and my y-intercept was 1. So I started at +1 on the y-axis, and I went up 3 spaces, and then over to the right 2 for each, and I just did that until I got off the grid. I used a solid line this time because it said or equal to, it was equal to, and the second thing is I shaded above the line. I shaded points that were higher than the line because it was greater than. Now I'm going to be doing the same thing with the second equation. On the second equation, -4x plus y is less than 3, I added 4x to both sides to give myself y is less than 4x plus 3. So because of that, I knew my slope was 4, or 4 over 1, and my y-intercept was 3. So I started at 3 on the y-axis, and I counted my slope of up 4 to the right 1 for each one, and then I'm going to connect the points with a dashed line because it's not equal to this time. And because this equation is less than 4x plus 3, I'm going to be looking at points that are below the line. So I'm going to be shading in the side that has points that would be underneath that blue line. Okay, now that I have my second equation shaded in, I'm going to be looking for that one overlapping section. So the one point where I had both red and blue was that small triangular piece that was at the top center part of the graph. Okay, so the next one I'll be working out fully if you need to see another equation that's been worked out all the way. Okay, this next equation we have y is less than or equal to 3, and x plus 1 is greater than 1. So this one's a little bit different, where I've got y is just less than or equal to 3. This is already y by itself. So what I'm going to do is I do not have a slope, because if I had a slope it would be in front of an x. So I'm just going to, I know that this is my b value of 3. So I'm going to be starting with a b on the y-axis at 3. And a rise over run of 0 would just be a flat line going to the right and to the left. So all of these are the points of y is equal to -3. So that's what happens when you have an infant. Okay, so we're going to be using +3. And we've got all of these y values that are when y is +3. And we're interested in when this is less than that. So this is going to be a nice easy one to color in, where we just shade in all this area that's underneath the line. And then I'm going to be looking at the second equation already of x plus y is greater than 1. So this time I need to get y by itself. So I'm going to subtract x on both sides. And that will give me y is greater than -x, +1. So that's going to tell me my y-intercept is +1. My slope is -1 from the negative sign here. And I'm just going to go ahead and make that -1 over 1. And so I'm going to go to my graph. I've got my y-intercept of +1 and my slope of down 1 and to the right 1. It's going to give me several points going to the right. And I'm going to reverse it to go to the left. So I'm going to go up one and left one each time. And this time, since it's greater than, it's not equal to, I'm going to go ahead and draw my dashed line. Now on this dashed line, I know it needs to be greater than that, so I need to be above it, so I'm going to be starting at the high side of that. I'm going to just go ahead and shade in all that area that's above that red line. Now our part of the solution is the part that's going to be in that boundary area, the part that's in that overlapping section of both the red and the blue. So I can see that, hey, this was my boundary line of the red and the blue section. I can see that the red and the blue was kind of in that bottom right area. And if we're looking for any values that would be considered a solution, it would be any point that would be from this purple section over here on the right. So any coordinate that would be on the right section, that bottom right section, would be considered a solution to this equation. Okay, so this third equation, or this third system, is a little bit different. We actually have three equations. So the nice thing about the bigger system is that they're already set up in y equals format. So I'm going to start with y is greater than or equal to 2x minus 3. I'm going to quickly graph the 2x minus 3, so starting at the y-axis at negative 3, using my slope of positive 2 to go to up 2 and to the right 1. Again, I want to use as many points as possible on this graph. Since it's or equal to, I'm going to go ahead and connect the dots here. And we're looking for points that are greater than that. So I'm going to just start a little bit above the line, and then I'm going to color in that whole side of the line of the graph. Now I need to be graphing my next line of the y is greater than or equal to negative 3. So this time I'm going to be starting on the y-axis at negative 3. And I'm going to go ahead and draw my solid line because it's or equal to, and it said y needs to be greater than that, and so I'm going to shade all the area above it. However, a system requires it to be a solution to all of the equations. So I can't just say, hey, it's that top left section right now. I don't have all my equations graphed. So what I'm going to do is I'm going to graph my third equation now. So negative 4 over 5 x plus 2. So I've got my y-intercept of positive 2 and a slope of down 4, right 5. I'm going to do that a couple of times just to get as many points as I can. And once I have all the points on the graph, I'm going to go ahead and use my solid line because this one is equal to. And this time it needs to be less than, so I'm going to start at a point just a little bit lower than the green line, and I'm going to color that in as green. Okay, so I've got one area that's really bounded by all three of these sections, and I'm going to just kind of highlight it. I can see right here that, hey, the part in the orange has the red, the blue, and the green this time. And so I'm just going to kind of highlight the boundary line here, just so we can have a real nice example of what this is going to look like. And then if you were asked for what is the solution to this system, any coordinate from that orange section, so say -5, +1, okay, we could say -10, 5, could say 0, 0. Any coordinate from that orange section would be considered a solution to this system. Okay, so the last one, we see a very strange equation. We've got y is less than or equal to -x + 2, but the second equation of x is greater than or equal to 3. We rarely see, so this equation doesn't even have a y in it. So we're going to start with just the regular equation, and then we're going to go to the x equation in a second. So I know my y-intercept on the y is less than or equal to -x + 2. My y-intercept is +2. My slope would be -1, so I'm going to go down and to the right. I'm going to go ahead and graph my points going back the other way. I want it to look as accurate as possible. And then I'm going to go ahead and connect my dots with a solid line because it's or equal to. And I'm looking at points that are less than that. So I'm just going to kind of start at a little bit underneath one of the points that I just graphed. I'm going to color in that whole side of the graph. Now our second equation of the x is greater than 3, this is a different equation because what this means we need to do is we need to find on the x-axis, because there is no y's on this, we're going to find the x-axis and we're going to find +3. So +3 on the x-axis, and this is actually going to have a straight vertical line. So it's rise with no run because we don't have that y equals equation. And so I went ahead and drew this, or we're going to go ahead and draw this with a dashed line just because we know that it's not equal to this. And now that we have that, we need to figure out which side of the line to color. So this says when x is greater than 3. So I'm going to think about this for a second. I need a number that's greater than 3. So I'm going to just say, well, if x was 4, that would be greater than 3. So I'm going to find +4 on the x-axis, and that's going to kind of tell me what section of the graph to color. And I want to color in the section with +4. And so I'm going to go ahead and shade this in the red here. And we can see the real nice little overlap section in that bottom right corner where we've got both the blue and the green, or the blue and the red. And I'm just going to go ahead and kind of outline it with the purple, so we can see where we're going to be at. And so any of the values, any point that would be in this section, like 4, -5, would be a solution. Okay, 10, -10 would be a solution. Any value that could be from that purple triangular area in the bottom right would be a solution to this. Now you do have an in-class assignment. When you're finished with the assignment, you must turn it in to Paula Shaw. Miss Shaw will collect them and give them to me at the end of the day. This is not going to be accepted late. It should be a pretty simple assignment. It's only graphing linear equations. If you have any problems, you need to let me know before class is over by sending me a message on Google Classroom. I hope you all have a good day, and remember, next time you will have a quiz. over the systems of linear inequalities that we did today, as well as the systems of equations with the quadratics that we did last time. Good luck, and I will talk to you guys next week.